Hello, in this lecture we will find out the value of angle theta. In the drawing we have triangle ABC. In triangle ABC, side CA equals to side CB. That is to say, triangle ABC is an isosceles triangle. In addition, we know that this angle ACB equals to 20 degrees in size. This angle NAB equals to 50 degrees, and this angle MBA equals to 60 degrees. Our mission is to find out the value of angle NMB, this angle that is actually also defined as angle theta. So first of all, we will copy angle ABC in a new page and we will analyze it. So actually, this is triangle ABC that I copied from the original drawing. In triangle ABC, this angle ACB equals to 20 degrees in size, and in addition, you know that side CA equals to side CB, and therefore we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And we also know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle ABC, theta plus theta is 2 theta, so 2 theta plus 20 degrees equals to 180 degrees. So we write it down. In triangle ABC, 2 theta plus 20 degrees equals to 180 degrees. We subtract 20 degrees from this equation, and we get that 2 theta equals to 180 minus 20, it is 160. We divide this equation by 2, and finally we get that angle theta equals to 160 degrees over 2, it is 80 degrees. This angle theta equals to 80 degrees in its size. This is also angle theta that is equal to 80 degrees in its size. So in the original drawing, this is angle theta, that in total it is equal to 80 degrees in its size, but part of angle theta, angle NAB, it is already equals to 50 degrees, therefore the rest of angle theta, this angle NAB, must be equal to 30 degrees. Repeat again, in order to complete the size of angle theta, this angle to 80 degrees, this angle must be equal to 30 degrees. In addition, likewise, we have, this is also angle theta that is equal to 80 degrees in its size, but this angle, part of angle theta, angle MBA, it is already equals to 60 degrees. Therefore, angle MBA, this angle must be equal to 20 degrees. In order to complete the size of this angle theta to 80 degrees, this angle must be equal to 20 degrees. Okay, in the next step I'll copy triangle NAB new page and we'll analyze it. Again, NAB equals to 50 degrees in size, and this is angle theta is equal to 80 degrees. Actually, this is triangle A and B that I copied from the original drawing. We'll define the missing angle as theta. In triangle A and B, the sum of the angles must be equal to 80 degrees. So 50 degrees plus 80 degrees plus theta. In total, the sum of those three angles must be equal to 180 degrees. 50 theta plus 50 degrees plus 80 degrees equals to 180 degrees. 50 plus 80 it is 130, so 130 plus theta. 130 degrees plus theta must be equal to 180 degrees. We subtract 130 degrees from this equation, and finally we get that angle theta. This is angle theta equals to 180 minus 130 is 50 degrees. So this angle theta equals to 50 degrees in its size. Angle theta is actually angle A and B. Angle A and B equals to 50 degrees in size. The original drawing, this is angle A and B that is equal to 50 degrees in its size. We continue to focus on triangle A and B. On triangle A and B, those two angles are both equal to 50 degrees, therefore they are equal to each other. And again, we have the rule that in front of equal angles in a triangle, there are equal sides. So in front of those two equal angles, we have those two sides that must be equal to each other. That is to say, side AB equals to side A. Side AB equals to side NB. AB equals to NB. Those two sides are equal to each other. I write it down here also. Side AB equals to side NB. Here also. Side AB equals to side NB. Okay, so in the next step we'll focus on triangle A and B. This triangle A and B, so I'll copy triangle A and B in a new page and we'll analyze it. Angle MAB equals to 80 degrees. This is angle MBA, it is equal to 60 degrees in its size. So actually, this is triangle A and B that I copied from the original drawing. We define the missing angle, this angle is theta. In triangle AMP, the sum of the angles must be equal to 180 degrees. That is to say, 80 degrees plus 60 degrees plus the missing angle theta. In total, the sum of the three angles must be equal to 180 degrees. 80 plus 60 is 140, so 140 degrees plus theta equals to 180 degrees. We subtract 140 degrees from this equation, and finally we get that angle theta, the missing angle theta equals to 180 minus 140, it is 40 degrees. So this angle theta equals to 40 degrees in its size. Angle theta is actually also angle A and B. That is equal to 40 degrees in its size. So we write it down in the original drawing. That this angle A and B equals to 40 degrees in its size. In the next step, we'll make a construction, that is to say from point B, we will draw line segment BD on CA in such a way that BD will be equal to BA. Okay? So, here we draw line segment BD. This is line segment BD. We draw line segment BD in such a way that BD equals to AB. BD equals to AB. Here we can write down that side BD equals to side AB according to our construction. So here we have side AB from one side, it is equal to side NB. According to this equation, from the other side, side AB also equals to BD. So we can write here that AB equals to BD, and from this equation, NB equals to AB equals to BD, we will derive that side BD equals to side NB. Side BD, this is side BD, this is equal to side NB. Those two sides are equal to each other. So, in the next step, I'll copy triangle ADB in a new page and we will analyze it. Again, side DB equals to side AB according to our construction. We can write down, this is triangle ADB that I called from the original drawing. Side AD equals to side AB according to our construction. Angle DAB, this angle equals to 80 degrees. Again, this is triangle ADB that I copied from the original drawing. Those two sides are equal to each other, and we have the same rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the missing angle must be also equal to 80 degrees. So we can write down that angle ADB, this angle ADB equals to 80 degrees in its size. The original drawing, angle ADB equals to 80 degrees in its size. We continue to focus on this triangle ADB. In triangle ADB, the sum of the angles must be equal to 180 degrees. we define the missing angle as theta. Therefore, in triangle ADB, 80 degrees plus 80 degrees plus the missing angle, that is angle theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 degrees plus theta must be equal to 180 degrees. We subtract 160 degrees from this equation, and finally we get that the missing angle theta equals to 180 minus 160, it is 20 degrees. So this angle theta equals to 20 degrees in its size. Angle theta it is actually also angle ABD. So angle ABD equals to 20 degrees in its size. Yeah. This is angle ABD that is equal to 20 degrees in its size. Okay. So in triangle here the small angle here, it is angle ABD that is equal to 20 degrees in size. The big angle is angle MBA that is equal to 60 degrees in its size. So the big angle MBA minus the small angle DBA will be equal to the missing angle. This missing angle is actually angle MBD. Repeat again, the big angle MBA minus the small angle DBA equals to the missing angle MBD. So I write it down and the big angle is angle MBA that is equal to 60 degrees in size, minus the small angle that is actually angle DBA that is equal to 20 degrees in size. It is equal to the missing angle MBD. This is the missing angle. Repeat again. The big angle, this is angle MBA, minus the small angle, that is angle DBA, equals to the missing angle, this is actually angle MBD. So the big angle is equal to 60 degrees, the small angle equals to 20 degrees, therefore 60 minus 20 it is 40 degrees. So the missing angle MBD equals to 40 degrees in its size. This is the missing angle MBD that is equal to 40 degrees in its size. In the next step, we focus on triangle DMB. So I copied this triangle DMB in a new page and we will analyze it. This is triangle MDB that I copied from the original drawing. We just right now found out that angle MBD equals to 40 degrees in its size. And we already found out that angle DMB, this angle DMB also equals to 40 degrees in its size. So I can write down in this drawing that this angle DMB equals to 40 degrees in its size. triangle DNB, we have those two angles that are equal to each other. Again, according to the same rule, that in front of equal angles in the triangle that are equal sides, we get that those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side DM equals to side DB. DM equals to DB. So right here, side DM equals to side DB. And here also, this is side DM that is equal to side DB. Okay, in the next step we will join points D and N together by a straight line. And we will focus on triangle DNB. We focus on the green triangle, triangle DNB. So I copy triangle DNB in a new page and we will analyze it. Angle NBD, this angle NBD equals to 20 degrees plus 40 degrees, that is 60 degrees. So this is triangle NBD that I call it from the original drawing. Angle NBD equals to 60 degrees in size. And we just right now found out that we already found out that dB equals to NB. dB equals to NB. Side dB equals to side NB. Side dB equals to side NB. And triangle DNB. Again, we have the rule that in front of those two equal sides, we have those two equal angles. So if this angle is theta, then the other angle must be also equal to theta. Again, the sum of the angles in triangle DNB equals to 180 degrees. That is to say, theta plus theta is 2 theta, so 2 theta plus 60 degrees must be equal to 180 degrees. We subtract 60 degrees from this equation, and finally we get that 2 theta equals to 180 on 60, it is 120. So 2 theta equals to 120 degrees, we divide this equation by 2, and finally we get that again theta equals to 120 over 2, it is 60 degrees. So this is angle theta that is equal to 60 degrees in size, and this angle theta also equals to 60 degrees in size. In triangle DNB, we have all those three angles inside triangle DNB are equal to 60 degrees, therefore triangle DNB is an equilateral triangle. Write it down, triangle DNB, the green triangle DNB is an equilateral triangle. And we know that all the sides in any equilateral triangle are equal to each other. So in the equilateral triangle DNB, side DN equals to side NB equals to side DB. So I write it down. side EN equal to side NB equals to side DB. dm equals to NB equals to dB. So we write it here also. That dn equals to NB equals to dB. So we'll focus on those two equations. The value of dB according to this equation, the value of dB according to this equation equals to dm. So we can write here that dB equals to dm from one side, but from the other side, according to this equation, dB also equals to dn. So we can write here that dB equals to dn. And finally, from this equation, dm equals to dB equals to dn, we derive that dm equals to dn. And dm equals to dn. Here, side dm equals to side dn. Okay, so in the next step we focus on this side of the straight line CA is point D. Okay. So this is the straight line CA. We focus on this side of the straight line CA is point DA. It's point D. This point. So which angles we have at this side of CA is point D. We have this angle that is equal to 80 degrees. This angle is one out the three angles of the equilateral triangle DNB, therefore it must be equal to 60 degrees. We also have this angle, this is the triangle MDN. Okay, so those are the three angles that we have on this side of CA, it's point D. 80 plus 60 is 140. 140 plus the missing angle must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, the missing angle MDN must be equal to 40 degrees in its size. So actually found out that angle MDN equals to 40 degrees in its size. In the next step, I copy triangle MDN, this triangle MDN in a new page and we will analyze it. So actually this is triangle MDN as I copied from the original drawing. We just right now found out that angle MDN this angle MDN equals to 40 degrees in its size. And we have already found out that dm equals to dn. Side dm equals to side dn. dm equals to dn. So in front of this, dm, this is dm, and this is dn. Okay? Here, side dm equals to side dn. Okay? Side dm equals to side dn. So in front of those two equal sides in triangle DMN, we have equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. Again, the sum of the angles in triangle DMN must be equal to 180 degrees. Theta plus theta is 2 theta, so 2 theta plus 40 degrees must be equal to 180 degrees in triangle MDN. 2 theta plus 40 degrees equals to 180 degrees. We subtract 40 degrees from this equation, and we get that 2 theta equals to 180 minus 40, it is 140. So 2 theta equals to 140 degrees. We'll divide this equation by 2, and we finally get that angle theta equals to 140 degrees over 2, it is 70 degrees. So actually this is angle theta that is equal to 70 degrees in its size, but angle theta is actually also defined as angle DMN. So angle DMN equals to 70 degrees in its size. Okay, so here we have angle DMN. This is angle DMN. This is equal to 70 degrees in its size. This is angle DMN, the big angle equals to 70 degrees in its size. So the big angle NMD or DMN that is equal to 70 degrees in size minus the small angle BMD that is equal to 40 degrees in size must be equal to the missing angle, that is angle theta, that is the angle that we are looking for. Again, the big angle DMN minus the small angle BMD must be equal to the missing angle, angle theta. That is the angle that we are looking for. So I write it down. The big angle, it is actually angle DMN, that is equal to 70 degrees in its size, minus the small angle, that is actually angle DMB, that is equal to 40 degrees in its size, must be equal to the missing angle, that is angle theta. It is also defined as angle NMB. I'll repeat again. The big angle DMN that is equal to 70 degrees in size minus the small angle DMB that is equal to 40 degrees in size must be equal to angle theta. The big angle is 70 degrees, the small angle DMB is 40 degrees, so 70 minus 40 it is 30 degrees. So finally found out that theta, the angle that we are looking for, that is actually defined also as angle NB, equals to 30 degrees in its size. And that is the answer to the question. This is angle theta, this angle theta equals to 30 degrees in its size. Angle theta, it is also angle NMB, that is equal to 30 degrees in its size. In the next step, I will summarize the lecture. Actually, in this lecture, we found out the size of this angle, angle theta, that is actually also angle NMB. Okay, it is given us the question that this angle in triangle ABC, angle ACB equals to 20 degrees in size. This is angle NAB that is equal to 50 degrees in size. And angle MBA, this angle equals to 60 degrees in size. Our mission is to find out the size of angle NMB that is equal to angle theta. So I copy triangle, and it is also given us as a question that side CA equals to side CV in triangle ABC. That is to say, triangle ABC is an isosceles triangle. So this is triangle ABC that I copied from the original drawing. Angle ACB equals to 20 degrees in size, and side CA equals to side CV. Again, we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides in triangle ABC, we have those two angles that must be also equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And you also know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle ABC, it means that 20 degrees plus theta equals to 180 degrees. Theta plus theta is 2 theta, so 2 theta plus 20 degrees equals to 180 degrees. Then we subtract the 20 degrees from this equation, and finally found out that 2 theta equals to 180 minus 20, it is 160 degrees. That is to say, 2 theta equals to 160 degrees. We divided this equation by 2, and finally we found out that theta equals to 160 degrees over 2, it is 80 degrees. So this is angle theta that is equal to 80 degrees in size, and this angle theta also equals to 80 degrees in size. So in the original drawing, we have those two angles, they are both angle theta. So part of angle theta, that is to say angle NAB, it is already equals to 50 degrees in size. Therefore the missing angle must be equal to 30 degrees. In order to complete the size of this angle, angle theta, to 80 degrees, the missing angle here must be equal to 30 degrees. Likewise, this is angle theta, that in total is equal to 80 degrees in size. But part of angle theta, that is to say angle MBA, it is also equal to 60 degrees in size. Therefore, the missing angle here must be equal to 20 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 20 degrees. Then I copied triangle NAB, this triangle in a new page, and we analyze it. This is a triangle NAB that I copied from the original drawing. Angle NAB equals to 50 degrees in size, and angle NBA equals to 80 degrees in size. Those are the two angles. So we define the missing angle here as theta. Again, according to the rule that the sum of the angles in any triangle is equal to 180 degrees, in triangle ANB it means that 50 degrees plus 80 degrees plus theta equals in total to 180 degrees. 50 plus 80 it is 130, so 130 plus theta equals to 180 degrees. We subtracted 130 degrees from this equation, and finally found out that the missing angle theta equals to 180 minus 130, it is 50 degrees. This angle theta equals to 50 degrees in size. Angle theta, it is actually also angle A and B. This angle A and B equals to 50 degrees in size. We continue to focus on triangle A and B. In triangle A and B, those two angles are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side AB equals to side NB. AB equals to NB. And you can write here also that AB equals to NB, and also AB equals to NB. Those two sides are equal to each other. In the next step, we focus on triangle A and B. So I copy triangle A and B in a new page and analyze it. So actually, this is triangle A and B that I copied from the original drawing. Angle MAB equals to 80 degrees in size, and angle MBA equals to 60 degrees in size. Those are the two angles. So we define the missing angle as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. That is to say 80 degrees plus 60 degrees plus theta equals to 180 degrees. 80 plus 60 is 140, so 140 degrees plus theta equals to 180 degrees. We subtracted 140 degrees from this equation and found out that 180 minus 140 it is 40 degrees. So finally found out that this angle theta equals to 40 degrees in its size. Angle theta, it is actually also angle A and B that is equal to 40 degrees in its size. So I can write down here in the original drawing that this angle A and B, that is theta, it is equal to 40 degrees in its size. Okay. So in the next step, we did a construction, that is to say from point V, we draw line segment VD in such a way, we draw line segment VD on CA in such a way that VD will be equal to AB. Again, BD equals to AB according to our construction. And I tell that BD equals to AB. So we have here two equations. According to the first equation, from one side, side A, AB equals to side NB. You can write that AB equals to NB. But from the other side, side AB equals to also to BD. Here AB equals to BD. And from this equation, AB, NB equals to AB equals to BD, we derive that BD equals to NB. Here, side BD equals to side NB. So, we will focus on triangle ADB. So I copy triangle ADB here and we analyze this. AD equals to DB according to our construction. In addition, you know that this angle DAB equals to 80 degrees. This is angle DAB that is equal to 80 degrees in its size. So in front of those two equal sides, there are those two equal angles. So, but this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees in its size. That is to say, we found out that this angle ADB equals to 80 degrees in its size. So we can write down here that angle ADB equals to 80 degrees in its size. We continue to focus on triangle ADB. The sum of the angles in triangle ADB must be equal to 180 degrees. That is to say 80 degrees plus 80 degrees plus theta, there is angle theta. In total, they must be equal to 180 degrees. 80 plus 80 is 160, so 160 plus theta equals to 180 degrees. We subtracted 160 degrees from this equation and finally found out that the missing angle theta is equal to 180 minus 160, it is 20 degrees. So this angle theta, that is angle ABD, equals to 20 degrees in its size. So angle ABD equals to 20 degrees in its size. This is angle ABD, the small angle, that is equal to 20 degrees in its size. So here we have the small angle ABD equals to 20 degrees in its size. The big angle, it is angle MBA, it is equal to 60 degrees in its size. So the big angle MBA that is equal to 60 degrees in its size, one of the small angle DBA that is equal to 20 degrees in its size must be equal to the missing angle MBD. This angle and angle MBD. So here, repeat again. The big angle MBA minus the small angle DBA equals to the missing angle MBD. The big angle equals to 60 degrees, the small angle equals to 20 degrees, so 60 minus 20 it is 40 degrees. So we found out that the missing angle MBD equals to 40 degrees in its size. This is the missing angle MBD that is equal to 40 degrees in its size. Then we focus on triangle MDB. Okay. So I copy triangle MBD in a new page and we analyze it. This is triangle MBD that I copied from the original drawing. We just right now found out that angle DMB or angle MBD equals to 40 degrees in size, and we already found out that angle DMB equals to also to 40 degrees in size. Here, this is angle DMB that is equal to 40 degrees in size. Again, you have those two angles in triangle DMB that are equal to each other, and according to the rule in front of equal angles that are equal size, those two sides must be equal to each other. That is to say, side DM equal to side DB. Here, side, this is side DM, that is equal to side DB, and wrote here also that side DM equals to side DB. Those two sides are equal to each other. In the next step, we join points D and N together by a straight line, and we focus on triangle DNB. And the green triangle, triangle DNB. So I copied triangle DNB in a new page and we analyze it. This is triangle DNB that I copied from the original drawing. What is the size of triangle NBD? From the drawing, it is very easy to see that the size of this angle DNB, the size of this angle NBD, this angle NBD or DBN is equal to 20 degrees plus 40 degrees, that is 60 degrees. So angle NBD equals to 40 degrees in size. This angle NBD equals to 40 degrees plus 20 degrees is 60 degrees. So angle NBD equals to 60 degrees in size. And we have already found out that DB equals to NB. Here, DB equals to NB. So here, this side DB equals to side NB. So those two sides are equal to each other. Again, according to the sum of that in front of equal sides in the triangle there are equal angles, we get that those two angles must be equal to each other. So if this angle is theta, then the other angle must be equal to theta, and the sum of the angles in triangle DNB equals to 180 degrees. That is to say, theta plus theta is 2 theta, so 2 theta plus 60 degrees equals to 180 degrees. 2 theta plus 60 degrees equals to 180 degrees. We subtract the 60 degrees from this equation, and finally found out that 2 theta equals to 180 minus 60 is 120 degrees. 2 theta equals to 120 degrees. We divided the equation by 2 and finally found out that the missing angle theta equals to 120 degrees over 2, it is 60 degrees. This angle theta equals to 60 degrees, this angle theta also equals to 60 degrees. So inside triangle DNB, we have all the three angles inside triangle DNB are equal to 60 degrees, therefore triangle DNB is an equilateral triangle. And we know that in any equilateral triangle, all the sides are equal to each other. And so in the equilateral triangle DNB, this equilateral triangle side DN equals to side NB equals to side DB. Okay, again. In the equilateral triangle DNB, side DN equals to side NB equals to side DB. So we can write here also that side DN equals to side NB equals to side DB. So we have those two equations. For one side, according to this equation, dB equals to dm. So I can write that dB equals to dm. But from the other side, dB also equals to dn. So I can write here that dB equals to dn. And from this equation, dm equals to dB equals to dn, we derive that dm equals to dn. Here, dm equals to dn. Here, side dm equals to side dn. Then we focused on the straight line CA, on this side of the straight line CA at point D. So which angles we have and this side of C8 point D, we have this angle that is equal to 80 degrees in its size. This angle is one out the fingers of the equilateral triangle D and B, therefore it is equal to 60 degrees, plus the missing angle MDN. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again. On this side of the straight line CA, this is CA. On this side of the straight line C8 point D, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So 80 degrees plus 60 degrees, it is 140 degrees. Therefore, the missing angle MDN must be equal to 40 degrees. In order to complete the sum of the angles on this side of CA at point T to 180 degrees, the missing angle MDN must be equal to 40 degrees. So here angle MDN equals to 40 degrees in its size. Then I copy triangle MDN, this triangle MDN, in this new page and we analyze it. So this is triangle MDN that I copied from the original drawing. We just right now found out that angle MDN, this angle MDN equals to 40 degrees in size. And we've already found out that DM equals to DN. Here, side DM equals to side DN. Again, we have the same rule that in front of those two equal sides, we have those two equal angles. So if this angle is theta, then the other angle is also theta, and the side triangle DMN, the sum of the angles must be equal to 180 degrees. So theta plus theta is 2 theta. 2 theta plus 40 degrees must be equal to 180 degrees. We subtracted 40 degrees from this equation. So 2 theta equals to 180 minus 40, it is 140. So 2 theta equals to 140 degrees. We divided this equation by 2, and finally found out that the missing angle theta equals to 140 degrees over 2, it is 70 degrees. This angle theta equals to 70 degrees in size, but again theta is actually angle DMN. Here angle DMN equals to 70 degrees in its size. So here we have this angle DMN, the big angle DMN equals to 70 degrees in size. The small angle DMB equals to 40 degrees in its size. So the big angle DMN minus the small angle DMB must be equal to the missing angle theta, that is the angle that we are looking for. So I repeat again, the big angle is DMN, that is equal to 70 degrees in size. Minus the small angle DMB, that is equal to 40 degrees in size, must be equal to angle theta, that is the angle that we are looking for. So the big angle is 70 degrees, the small angle is 40 degrees, so 70 minus 40 is 30 degrees. So finally found out that the missing angle, this missing angle theta, that is also defined as angle NMB, it is equal to 30 degrees in its size. Okay, thank you very much.